All right, so this is an exam from 1970s. Maybe your parents took this exam, the Calculus AP exam in 1970. And as you can see, it's just transformations. And it's missing some transformations. I wish I would have put some more in there myself. And yes, we're doing Algebra 2 first. I think it helped first period, so I think it's going to help you guys as well. Hopefully the internet's not going to be lagging as extreme as it was first period. So let's get right into it. So here's the original function. I'm going to create a table, guys. I'm going to be plotting these points specifically. -3, -3, -2, -2, -1, -1, 0, -1, 1, 0, 2, 1, and 3, 0. So those points that you see there, I'm going to be plotting them in a table. So -3, -2, -1, 0, 1, 2, 3. And so we said a -3, that's -3. A -2, that's -2. A -1, that's -1. 0, -1. 1, 0, 2, 1, and 3, 0. So there it is. I just made a table, and it's just your coordinate points. So that's the original. So it says on the axis provided, sketch an entire graph of y equals absolute value of f of x. Notice the absolute value is on the outside. So if you want to get ahead of me, guys, go for it. No big deal. So x and then absolute value of f of x. So let's see. -3, -2, -1, 0, 1, 2, 3. So this here means absolute value of f of -3. And f of -3 was -3. So absolute value of -3 is simply 3. So at -3, put a point at -3, 3. -3, 3. This now means absolute value of f of -2, which means -2 was -2. F of -2 was -2. So I'm going to plot a point at -2, 2. Absolute value of f of -1 is f of -1, which was -1, which is going to be 1. So -1, 1. Absolute value of f of 0, that was -1 again, and absolute value of -1 is 1. So 0, 1. And then this one is absolute value of f of 1. F of 1 was 0, so absolute value of 0 is just 0. This was absolute value of f of 2. F of 2 was 1, and absolute value of 1 is just 1, so 2, 1. And then again, absolute value of f of 3. F of 3 was 0, so absolute value of 0 is just 0. So then we just plot them. And there it is. What happened? Anything that was in quadrant 3 and 4 just got reflected across the x-axis. Anything in quadrant 3 and 4 was reflected across the x-axis. And it makes sense. Anything that's below the x-axis, the y values are negative. Since I put absolute value of the y value, yeah, it's gonna reflect all my negative values to positive values. It's gonna turn them all those negative y values are gonna turn them to positive values. Does that make sense? Virtual class, does that make sense?
Yes.
Okay.
Yeah.
And then of course, you already have these y values here. They're untouched because they're already positive to begin with. So that's the only part that was untouched there. And then everything that was below the x-axis was just reflected. All right, let's keep going. So notice now, and I'm going to use blue for the absolute value thing. Notice that now the absolute value is for inside of x. Actually, no. -3, -2, -1, 0, 1, 2, 3. We're going to be looking at the original one. Hopefully I don't make the mistake I did this morning when I was looking at not the original. So this means f absolute value of -3, which absolute value of -3 is just 3. So then I just look for f of 3. And f of 3, if I go back here to the original, f of 3 is just 0. So I'm going to put 0. So at -3, put a point at -3, 0. F absolute value -2. That's just f of 2. And f of 2, I believe, was 1. Let me just check. F of 2 is 1. Yep. So at -2, go to -2, 1, and put a point. F absolute value there, like so. -1. Absolute value of -1 is 1. And f of 1 was 0. So -1, 0. I think -1 was 0. I mean, f of 1 was 0. Let me check. Yep, it was. This one, absolute value of 0. I guess some can make the case, why even bother? Just call it f of 0. You're right. F of 0 was -1. So 0, -1, point. All I'm doing, guys, is getting it from here, the original. I can see 0 is -1. So let's see. And then these are just going to be the same because absolute value of 1. And here's where the absolute value sign is. It's up that way right there in blue. That's just f of 1. And f of 1 was 0. So 1, 0, point. This is f of 2. F of 2 was 1. The absolute value signs are those. And so 2, 1, put a point. And f absolute value of 3. And I know what some of you are saying. Why are you even putting absolute values if you already know they're positive? Sorry, guys. I just want to be technical. I'm not trying to make your life harder. And here's what we get. What happened? Compare that graph to the one on number 1, to the original. What does it look like happened, guys? All your x values that were negative were deleted, and you reflect whatever is in quadrant 1 and 4. Do you guys see that? So I'm going to put original values in quadrant 2 and 3 are deleted. I can't speak today. Comma. Original values in 1. Original values in quadrant 1 and 4 are reflected across y-axis. You know what? We could have just put symmetry on the y-axis. Symmetric about y-axis. What do you think, Rubio? You happy, miss? All right. Are you loving math life? All right, good. That's what we want to hear. You think your friends that are on the other side of Zoom are loving math life right now? Okay. Or do you think some of them are taking a nap? All right, because they're taking a nap. It's a demerit.
You are yawning, Chav.
I know, because you guys pass me
That's a
those
demerit.
vibes.
That's half a demerit.
Y'all are funny. All right, guys, this one's going to be pretty straightforward. I'm no longer tired. Math gives me energy. Math gives me strength. So I now have the energy to keep going. So all that negative on the inside, all it does, guys, is just change the sign. So if you want, you can just say change polarity. So if it's negative, it's now positive. If it's positive, it's now negative. I'm talking about only x values. I'm not talking about the y value. The y value is still indicative of whatever I have of f of negative x. What does that mean? Chavez, I don't understand anything you're saying. That's supposed to be you guys right there. Maybe you guys don't talk exactly like that, but okay, so here's what I'm trying to say. So this says f of negative and then negative 3, because that's what my x value is. Negative times a negative is a positive. So I'm looking at f of 3. So if I go back to the original, and I look what f of 3 is, f of 3 is 0. So that's what I'm doing, guys. So I'm not going to show all these details. I'm just going to go negative. I'm just going to change the sign. So this is f of 2. Oh, by the way, I should apply the point, right? Negative 3, 0. Negative 3, 0 right there. F of 2, I believe, was 1. So let me know, because I make mistakes all the time. Negative 2, 1. So this is going to be f of 1. And I believe f of 1 was 0. So negative 1, 0. And then this is f of 0. F of 0 is negative 1. So 0, negative 1. And then now this one is going to be f of negative 1. F of negative 1, I believe, was negative 1. So 1, negative 1. F of negative 2. F of negative 2 was negative 2. So 2, negative 2, point. And then finally, f of negative 3. And I believe that was negative 3. So 3, negative 3, point. And then no reason for sound effects if you don't want to do sound effects. And there it is, guys. What do you guys notice? What do you nerds notice?
It's the opposite. It's flipped on the y-axis.
It's flipped on the y-axis. Reflected across, everything is reflected across the y-axis. I'm going to put everything in quotes. You can say flipped. That's perfectly fine. Everything is reflected across y-axis. You can say flipped. I think flipped is probably the better word. All right, let's keep going. Ooh, look at this. We have a half in front of the x. If you ever see any of these, if you see on my comments on Canvas, if you see this on Canvas, that's an awkward face. And I put that like every time I see something and I'm like, why'd you do that for this number? Awkward. Or, you know, on the exam, I'll do that. Anyways, that's besides the point. How does the table look? Let's see, if I have half, I need to put values that I know. So, all right, I'm gonna explain these numbers in a little bit. For now, just write them down. Negative 6, negative 4, negative 2, 0, 2, 4, 6. All right, so what I'm doing here, guys, why did I choose those numbers in particular? Because I'm taking half of those values and I wanna force myself to use just these points. These right here, the original. You don't have to use this table. If you like using graphs, you can use graphs. No big deal. I'm forcing myself to use those original points. I think it's easier to read this from a table, but if you're used to reading it from a graph, that's fine. So f of, let's see, half of negative 6. Well, half of negative 6 is just negative 3. So then I look for f of negative 3, and f of negative 3 is negative 3. So go to negative 6, negative 3, put a point. I'm doing the same thing. Half of -4 is -2. F of -2 is -2. So go to -4, -2, put a point. Half of -2 is -1. So I go to -1. So -2, -1, put a point. Half of 0, well, it's 0. So 0 is always going to be, so that's going to be -1. Wait, this one was -1. I didn't put it in there. So 0, -1, put a point. Let me know if I make mistakes, guys, because I make mistakes all the time. Half of 2 is 1. F of 1, I believe, was 0. So 2, 0, point. Half of 4 is 2. And f of 2 was 1. So 4, 1, point. And then half of 6 is 3. And at 3, it was 0. So 6, 0. So hopefully, if I didn't do any mistakes, it looks like that. What did you guys notice? What did you nerds notice? Okay, I'm gonna stop, guys, because I don't know, maybe some of you guys are getting annoyed by me saying that, so I apologize. I can assure you that is not my intention. So what did you guys notice about this question? About this, what did that half x do? What did that half do? That's what I'm gonna write down. Is it a stretch or compression? Stretch, by what factor? Not by factor of half, by factor of 2. The reciprocal, whatever this is, the reciprocal of that. Horizontal stretch by a factor of 2. All right, was that the last one? No, we got one more. You already know what's gonna happen here, probably. So if you don't, no worry. We're gonna go ahead and write it down. So look where I'm gonna start at. I want this to be a -3, so -2. -2, -1, 0, 1, 2, 3, 4. I don't think anyone's confused about why I started at -2. -2 minus 1 is -3. F of -3 is -3. So go to -2, -3, put a point. F of -1 minus 1 is -2. And f of -2, oh, by the way, no, it's all correct. It's just that I have a habit of, I want to at least show one the full work. F of -2 minus 1, that's f of -3, which is -3. It was correct. I just at least want to show work for one of them. All right, -1 minus 1 is -2. F of -2 is, I actually forgot what f of -2 was. Was it -2? So -1, -2, point. F of 0 minus 1, that's f of -1. F of -1, is it -1? Let me check. F of -1, yep, -1. F of, let's see, 0. Oh no, that's a 1. 1 minus 1, f of 0. F of 0 is -1. So let's see, -0, -1, 1, -1. F of 2 minus 1, that's f of 1, which is 0. So 2, 0. F of 3 minus 1, that's f of 2. And f of 2 was 1, so 3, 1. And f of 4 minus 1, that's f of 3. And f of 3 was 0, so 4, 0. What happened there?
It moved to the right. A horizontal shift to the right by 1 unit.
Perfect.
Oh, Chop, I'm a little confused on where you're getting the numbers from for the y values.
Oh, you see how I'm circling f of -3?
Mm-hmm.
So I just come up to the very first one and I say, this is f of x, so f of -3 is -3. So let me look at one that is not the same number. See this one, how it says it says 3, 0? That one means f of 3 is 0. That's what it means. So That's the last one here. I plug in a 4 into my f of x minus 1. So f of 4 minus 1, that's f of 3. So I get 0. So my x coordinate is 4, and my y value is 0. So I'll put a point at 4, 0. That makes sense?
Yeah, so that's why with, I think it was like the third graph, the first 3 negatives, when you turned them into absolute value, they turned into positive numbers. And that's why they had the, okay.
Yes, because it was absolute value of the inside of that, of your argument. Cool?
Yes.
Yay. It has a weird smiley. So that's fine. I'm remembering, I don't know, okay, I remember all these random things at random times. I remember one time I smiled and I think someone said, your smile's a little crooked. And I'm like, oh, thanks. Thanks for pointing out my flaws. Oh man, life is awesome. Life is awesome, guys. All right, so now that we're done with that, hopefully that helped. Did that help, like, understand the transformations a little bit or no? Okay, so here we go. It says the figure below shows a quarter of a cycle. So this is 25%, guys, in degrees. Write a particular equation of the wave. All right, I want to see this wave. This has to be a point of inflection. This has to be a min. So, and then this is a midline. That's 25%. What is this gap? 17, 8 to 19, 20, 1, 2, 3, 4, 7 degrees. Okay, before I draw anything, can you tell me what the period is just by looking at that? What is it? You're close. 14 is half a period because this that I just drew, this green line, is just 25% of a period. So what do you think my whole period is?
28.
28 degrees. And we get 28 degrees from doing 7 times 4. See? All right. I want to draw this because I want to see like the whole graph, like a whole cycle. So I'm going to continue. I'm going to see if I can keep the gaps the same. So if I go, oops, that's zoomed in too much there. Let's see. If I go another 7 to the left here, so there I am at 10. And I guess I should have done the amplitude, huh? So the difference between 8 and 3 is 5. So I'm going to go another 5 up. I'm going to say right there, 8, 9, 10, 11, 12, 13. So I'm going to say that's 13. And at 10, I'm at 13. And I'm going to do this. And there's my concave up. I mean, concave down to concave up. Sorry. I'm all over the place there. All right. I want to see a whole cycle. So right now I have 50%. So I'm going to go another 7 to the right here. So I'm going to be, I don't know, somewhere like, let's see, somewhere like right there, 31 degrees. That's a 10 degree there. And I'm going to be at a point of inflection. So there it is, concave up. And then I'm going to go another 7. I'm going to say that's 38 right there. And at 38, put a point at maximum. And there it is, guys. It looks pretty good. If I went another 7 this way, I'd be at 3. Let's see, points. And there it is. I think it looks pretty good. What do you guys think? All right, let's write some stuff. It wants a particular equation. What do you guys want to use, cosine or sine? Cosine? All right, cosine. They told me cosine. So they want to use cosine. Oh, I would put an X, but they're using theta, so we're going to use theta. All right, the amplitude. What's the amplitude, guys? The difference between 8 and 3. You could also do the difference between 13 and 8. It's the same. Not everyone at the same time. Yeah, 5. It's okay to be wrong, guys. All right, let's see. What is our B? Well, before we can get the B, we know what our period is. Our period is 28 degrees. So that will give us our B. So that means our B. Oh, somebody told me that the period equals B. It does not. Some of you guys told me that on that handout activity, and I took away 5 points. Do not tell me that the period is B. The B is 360 divided by the 28. So 360 divided by 28, 360 divided by 28 is 90 over 7. And do not put any degrees on it. That's your B. And we're right now in a little bit, we're going to talk about that. The C, I'm going to have to use a peak. I'm going to use my first peak. I see a peak at 10 degrees. So 10 degrees to the right, because we're using cosine. And finally, the sinusoidal axis is the D, and that happens to be 8. So I got everything I need. Y equals 5 cosine 90 over 7, parenthesis, x, oh, not x. We won't count it wrong if you write x, but let's try to be proper here. Theta minus 28 degrees. There I am with 28. Erase the 28, put the 10. 10 degrees, close, close, plus 8. Now, if you are taking an SAT and they tell you an equation of a graph, and they tell you just real quick without a calculator, well, normally they put the B a lot nicer than 90 over 7. But if they tell you what is the period, remember that we just talked about what happened on this one. Look, whatever that number is, we took the reciprocal, and that's what happened, right? Like that's what, we took the reciprocal, and that's how we knew our scale factor. So this right here, if I take the reciprocal of that, it will tell me my period. It won't tell you the period immediately. So you have to go 7 over 90. Now, 7 over 90 times what? Well, what should have been the period? What's the period of a parent function, of a parent sinusoid? 360. So 7 over 90 times 360 is 28 degrees. OMG. Do you guys see how all this is coming together? This is a horizontal compression by 7 over 90. By scale factor. And where am I getting the 360 from, guys? The parent function y equals cosine x, or cosine theta. Parent function has period 360 degrees or 2 pi if you're in radians. Is this making sense to everyone? Virtual class, is this making sense to you guys?
Yes.
Okay. All right, I think we're good. Let's keep going. Example 2. And don't worry, guys, we're almost done. We're almost done. We're going to be done pretty soon here. This graph that you see is the exact graph that we just drew. It's the exact one. So it says the equation we came up with as a class. Okay, well, the equation we came up with is this one. So let's write that one in. Y equals, so let me do it in red. I like red better than. Y equals 5 cosine 90 over 7 theta minus 10. Degrees, close, close. Plus 8. You still okay? All right. So here we go. It says, for this sinusoid, write a particular equation using cosine with a phase displacement other than 10 degrees. Okay, so that means do the same equation, but they don't want to see a 10 though. Y equals 5 cosine 90 over 7 theta minus, we'll figure out that one in a little bit, plus 8. I got to look for another peak besides 10. Is there another peak besides 10 degrees? Yeah. 38 degrees. There it is. Virtual class, are we still okay?
Yes.
Okay. Next, I want a sine function. Remember, guys, how the sine function looks like. I'm going to write it right here, a little sketch. Sine x, I'm looking for a point of inflection on the way up, and it has to be a point of inflection. Since they told me 25% of a cycle, I know for a fact, that at 3 degrees is a point of inflection going up. Because I know that this is going to be my reference. So that's the one I'm going to use. Y equals, everything is exactly the same. The only difference, instead of cosine and instead of 38, I'm going to use sine, and I'm going to use 3. 5 sine 90 over 7 theta, that's a theta, minus 3 degrees, close, close, plus 8. Does everyone understand where we got the minus 3 degrees from? Guys, I need to hear back from you guys. Do we understand that?
Yes.
Okay. We're using sine x. And remember, when you're using sine x, you have to use a point of inflection on the way up. Because that was, our point of inflection was at the midline, right? And that's that first point of inflection at the midline going on the way up is at 3 degrees. All right. This time it wants cosine with a negative vertical dilation. All right. Don't write anything down. Just listen. Do you guys agree? Don't write anything down. Just listen right now for now. That if I were to put a negative in the front, and we didn't do it, so I wish we would have done it on this one. If I were to put a negative in the front, how does that change this graph in green? Yeah, it would just turn, whatever's a max will turn into a min, whatever's a min will turn into a max. So if I put a negative there, notice where I put the negative, it would do this. Those points of inflections will still be points of inflection. It will look like this. And don't write this down, just listen, guys. It looks kind of like a DNA a little bit. All right, don't write anything down, just listen. What if I told you I want the equation of that black line? Can you give me the equation of that black line? The black one. Y equals 5. Don't worry, we're going to write this down. Not yet, though. 90 over 7. Theta minus, give me one of the peaks. 24. Close, close. Plus 8. So there it is. That's the equation of the black line. That is not the one I want. I want the one in green. So does everyone agree that if I put a negative in front of this, that this black line will turn into the one in green? There it is. That's how we're going to do it, guys, with logic. So this is what they want. They want the negative in front of the cosine. There's a negative right there. So I'm going to come in here and I'm going to write y equals negative 5 cosine 90 over 7 theta minus, and don't worry, I'm going to give you guys time to write, theta minus 24, close, close, plus 8. All right, so gather your ideas and go for it and write down what we just did. All right, how do we feel? Are we okay? Are we okay so far? All right, last one. Sine with a negative vertical dilation factor. Again, I'm looking at the black line, and I'm looking for a point of inflection going up. I see one right here at 17. Do you guys see that one? So I'm going to write y equals, for now, I'm not going to put a negative. I'm just going to put 5 sine 90 over 7. Theta minus 17 degrees, close, close, plus 8. So write that down real quick. I'm trying to get both of them in here. All right. Does everyone agree that currently the equation that I have written in red gives me the black curve? Do I want the black curve? We want what curve? The green one. So in order for me to get the green one, what do I put on the front of this? A negative. Does that make sense? There it is, guys. Now, I know there's probably some students out there that don't want to ask me. I very rarely ever call you guys students. I apologize, guys. I call you guys my kids because you guys are my kids. So there's probably a few kids out there that don't want to ask me why, when you put a negative, why does it do that? Because remember when you had a function y equals f of x, and then you put a negative in front of it. So what happens? So if I have a function, this is y equals f of x in red. And if I put a negative in front of it, all that does is whatever was positive turns into a negative. So it does this. See? Does that make sense? And then all this plus 8 is doing is just making that curve in blue go up. So in case you didn't want to ask, that's what's happening, guys. If this is bringing you a lot of confusion and a lot of stress, please show up to tutoring tomorrow. I will have tutoring tomorrow, guys. All right, let's all come back.